Mathematical equation for a straight line graph. You know it. Y equals mx plus b. Suppose you had found a graph that had a function of f of x equals 3x squared plus 4, which quantity should be graphed in order to make a straight line slope. So we're going to do y equals mx plus b. When we do this, all right, so I'm not changing colors. We'll see on the y-axis, we're going to graph f of x. On the x-axis, we're going to graph x squared, which will give us a slope of 3, straight line. And then our b is going to be that plus 4. So on the vertical axis, we would do f of x. And then on the horizontal axis, x squared. Suppose you had found a graph that had a function of t equals 2 pi times the square root L over g, which quantity should be graphed in order to make a slope that is a straight line that represents g. There's 2 different ways to handle this. First, I'm going to go through the way that I walked through in the PowerPoint, the previous video, and that is lining it up with y equals mx plus b. So we want a slope that will represent g. Let's see what we can get when we rewrite this. T equals 2 pi times the square root of L times the square root of 1 over g. So we can do y equals m, we want g, and then x. 2 times 3 is the same as 3 times 2. Commutative property of multiplication. I'm switching x and m there. So on my y-axis, I'm going to graph t. On my horizontal axis, I'm going to graph 1 over g, square root of 1 over g. No! That's what my slope's going to be. On my x-axis, I'm going to graph all of this junk, which we can do 2 pi times the square root of L. That's an acceptable answer. We can also recognize that 2 and pi are constants, so they're not really going to change anything. So we can just do t versus square root of L. And our slope will be the square root of 1 over g. Now, hopefully that's making a lot of sense to you. Let me show you an alternative way that perhaps will make even more sense to you. I know it's going to be a lot easier once you do get it, so hang with me there. I'll leave that in blue, and I'm going to try to change colors again, and again it's failing me, so terrific. Starting with t equals 2 pi square root L over g, I'm going to solve for g. To do that, I'm going to square both sides of this equation. So I end up with t squared equals 4 pi squared times L over g. My next step, I'm going to multiply by g on each side. And kind of at the same time, I'm going to divide by t squared. So my equation becomes g equals 4 pi squared over t squared. Oh, 4 pi squared L over t squared. There we go. So I've solved for g. Who cares? What good is this? Well, there's another formula that you know about slope. Remember, that's what we're looking for. And that is slope is equal to rise over run. So if I solve this equation and I end up with a fraction, like I did over here, then rise over run, g is my slope. So I put all of this on my y-axis, my rise, and then my t squared on my x-axis, because that's my run. So again, I can ignore the constants if I like. So here I could do L, and over here I could do t squared. Both of those are correct answers. There's even another correct answer that we could have. And that is if you have t squared versus L, because you squared both sides of it. Notice that they are the inverse of each other. And when we did the first way, we were getting the slope being the square root of 1 over g, so there's the inverse. Okay. Perform linearization for each of these equations so that two quantities could be graphed to yield a straight line together whose slope could be used to determine c. Okay, so we have y equals mx. So here we're going to do y versus x. What I'm doing here is I'm showing my y-axis versus my x-axis. This is how we name our graphs in physics. The y-axis is our dependent variable, and our x-axis is our independent variable, the one we change. Over here, this would be y versus x naught. Sorry, I missed that exponent there. So this would be y versus x naught. This one is going to be y versus x. This one right here is going to be y versus x squared. Remember, we're starting with this curved graph, and what we're doing is we're making it linear. So that way we can easily calculate the slope at all points and make better predictions, which is what we do in physics. Here, for a square root graph, we can do y versus square root x. That will linearize it. This one, that's linear, but it has a y-intercept. Notice the difference here. There is no plus b with the directly proportional, and there is a plus b for a linear. That's the difference between a directly proportional graph. Directly proportional, the slope will go through the origin. For the inversely proportional graph, we're going to do y versus 1 over x to make that a straight line. An inverse square, y versus 1 over x squared. And then by now you've picked up on the pattern. Y versus 1 over square root x to linearize the inverse root. There's more? Okay. What to graph to obtain? I think this is what we just did. So I just wrote right on it. Sorry.